Find all zeros of the polynomial p of x equals 12x to the fourth plus 20x cubed minus 41x squared plus 20x minus 3. First thing we're going to do is find all the rational zeros, all the possible rational zeros. So I'm going to take the factors of the constant and the factors of the leading coefficient and look at those. Factors of the leading coefficient are 1 and 12, 2 and 6, 3 and 4. Factors of the constant, 1 and 3. Take the constant, plus or minus 1, plus or minus 3. That's dividing by 1. Now I'm going to take each of these, 1 and 3, and divide by 2, 3, 4, 6, and 12. So plus or minus 1/2, plus or minus 1/3, plus or minus 1/4, plus or minus 1/6, plus or minus 1/12. Now I'm going to take the 3 and divide by 2, 3, 4, 6, 12. Plus or minus 3/2, plus or minus 3/3, plus or minus 3/4, plus or minus 3/6, plus or minus 3/12. And notice some of these simplify. Plus or minus 3 over 3 is 1. Plus or minus 3 over 6 is 1/2. And plus or minus 3 over 12 is 1/4. So I have some of those again. Okay. So let's go ahead and also do Descartes' Rule of Signs. I'm going to rewrite my polynomial, 12x to the fourth plus 20x cubed minus 41x squared plus 20x minus 3. I'm going to look for variations in sign. I have 1, 2, 3. So there are 3 or 1 positive real zeros. Remember, we look for variations in sign. That gives us a 3. Then we subtract by 2 until we get different integers. We stop if we get something that's going to be less than 0. Then we do p of negative x. And we plug in negative x into x in every single position. When we do so, we have to change the signs of the terms that have odd powers for x. So the even powers have the same sign. So 12x to the fourth stays positive. Plus 20x cubed changes to minus 20x cubed. Minus 41x squared remains the same. Plus 20x turns into minus 20x, and then I have my constant minus 3. Look for variations in sign. I have 1, and that's it. So there's 1 negative real 0. I also need to check p of 0. I see p of 0, if I plug a 0 in for x, I get negative 3. So I see that 0 is not a root, or not a 0. Okay. And notice this is 3 or 1 positive real zeros, 1 negative real 0. All of these I have listed here are rational zeros. So, I could get something like 1 plus the square root of 2 is a 0. Okay, so let's just start with some synthetic division, just see what we have. So I put the coefficients. Remember, you always want to check your powers. My exponents go 4, 3, 2, 1, 0. If I was missing one, I would put a 0 to replace that term. And I always want to make sure my powers are in descending order. Looks like everything's good, so I write my coefficients, 12, 20, negative 41, 20, negative 3. And I'm just going to choose positive 1. It's always a good place to start. I bring the 12 down. 1 times 12 is 12. 20 times 12, 20 plus 12 is 32. 1 times 32 is 32. Negative 41 plus 32, well, that's a negative 9. And I have 1 times negative 9 is negative 9. Positive 20 plus a negative 9 is positive 11. 1 times 11 is 11. Negative 3 plus 11 is positive 8. So this is not a 0. And it's always nice just to check and see if it tells us if it's an upper bound or anything. In this case, it does not. To be an upper bound, all the signs had to be positive. Okay, so let's try something else. Just for fun, I'm going to go and try one of the fractions because a lot of students are scared of fractions. So I'm going to go ahead and try, I don't know, let's try 1/3. So 12, 20, negative 41, 20, and negative 3. I'm going to scroll down just a little bit. So I get 12. 12 times 1/3, that's 12 divided by 3 is 4. 20 plus 4 is 24. 24 times 1/3 is 8. Then I have negative 41 plus 8, so I end up subtracting to get negative, 33? Negative 33 times 1/3 is negative 11. 20 minus 11 is 9. 9 times 1/3 is 3. Oh, good. Negative 3 plus 3 is 0. Good, good, good. So I see 1/3 is a 0. Let me do it in red. 1/3 is a 0. That also means that x minus 1/3 is a factor. Okay? So I'm going to go ahead and rewrite my polynomial, p, in terms of my new factor. So this is x minus 1/3. Remember, we're always kind of keeping an eye. This last column talks about, always gives me my remainder. So I'm going to use these coefficients. My original function had the power x to the 4th as a leading power, so now I'm going to drop it by 1. I have 12x cubed. 12x cubed, I'm going to use these numbers right here as my coefficients, starting with x cubed, plus 24x squared minus 33x plus 9, like that. And anytime you can, you want to try to clean things up. If you notice, every single term in this second piece, this new polynomial, can be factored. I can factor out the 3 out of all the pieces. So this is like p of x equals 3 times x minus 1/3. 3 times 4 is 12. 3 times 8 is 24. 3 times 11 is 33. And 3 times 3 is 9. So I end up with that. So I'm going to look at this piece right here, and I'm going to try to continue with my synthetic division from there. Remember, anytime you can get to a point where you can factor, you want to go ahead and do so. We've reduced a lot of our zeros now. I have the factors of 3, so I have plus or minus 1, plus or minus 3, and I'm dividing by factors of 4. This is 1 and 3, this is 1 and 4, and 2 and 2. So then I have plus or minus 1/2, plus or minus 3/2, plus or minus 1/4, plus or minus 3/4. If you've noticed, I've eliminated a lot of zeros. Look at all the ones I had up here. I saw that 1 was not a 0, so if 1 was not a 0 up there, it's not a 0 here. So I have negative 1 plus or minus 3, plus or minus 1/2, plus or minus 3/2, plus or minus 1/4, plus or minus 3/4. And my Descartes Rule of Signs told me I had 1 positive real 0 or 3 of them. So at this point it's not real clear if we have more positives or not. We shall see. Do you see that I eliminated a whole bunch of the possible rational zeros? So let's just try one. Okay, some people like to try -1, so let's go ahead and do that. We always try from the new simplified equation. 4, 8, negative 11, and 3. I'm going to try -1. 4, negative 1 times 4 is negative 4. 8 minus 4 is 4. Negative 1 times 4 is negative 4. Negative 11 plus a negative 4 is negative 15. Negative 1 times negative 15 is 15. 3 plus 15 is 18. Again, negative 1 is not a 0, so I can X that one out as well. Okay. Let's try, I guess, positive 3. What happens if I try positive 3? 4, 8, negative 11, and 3. Bring the 4 down. 3 times 4 is 12. 8 plus 12 is 20. 3 times 20 is 60. 60. Negative 11 plus 60 is 49. 3 times 49 is 147. 147 plus 3 is 150. If you notice, all of the numbers in the bottom row are positive, so this tells me 3 is an upper bound for the zeros. Doesn't really matter because 3 was the biggest number we had, but 3 is not a 0, but it's an upper bound. Okay? So what should we try next? We could try -3, positive or -1/2, positive or -3/2, positive or -1/4, or positive or -3/4. So let's just go ahead and try another fraction because those are always fun. How about 1/2, 4, 8, -11, and 3. Bring the 4 down. 4 times 1/2 is 2. 8 plus 2 is 10. 10 times 1/2 is 5. -11 plus 5 is 6. 6 times 1/2, I'm sorry, it's -6, just kidding. 6 times 1/2 is -3. -6 times 1/2 is -3. -3 plus positive 3 is 0. Looks like 1/2 is a 0. So that means x minus 1/2 is a factor. Let's rewrite our polynomial. P of x equals 3 times x minus 1/3. That was the piece from before. Now I'm going to take this piece and I'm going to write x minus 1/2 times 4x. Remember, this was my remainder. So I have 4x squared plus 10x minus 6. If you notice, we can also factor out 2 here. So 3 times x minus 1/3, x minus 1/2, I can factor out a 2 and get 2x squared plus 5x minus 3. If I want to pull the numbers up front, I can. 3 times 2, I have a 6, times x minus 1/3, times x minus 1/2. I'm going to try to factor this. Okay, I have a minus 3, which means signs in parentheses are different. I need factors of 1 and 2 and 1 and 3 that subtract to give 5. So I have a 2x and a 1x. So 2 times 3 is 6, so 3 has to go here. Right, 2 times 3 is 6, minus 1 gives me 5. This has to be the 1. I want the biggest one to be plus, since the sign in here is plus, so check that. So 2x times x is 2x squared. 2x times 3 is 6x. -1 times x is minus x. That gives me my 5x. And -1 times 3 is -3. Okay, looks like we have it. So my zeros are 1/3, 1/2. What happens here? We say 2x minus 1 equals 0. So 2x equals 1, x equals 1/2. I got 1/2 again, right? And then here x plus 3 equals 0, x equals -3. So 2 has, 1/2 has multiplicity 2. And that's it.